Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on December 15th, 2025, just 2 days ago. It introduces Steer3D, a way to edit 3D assets with plain language in a single forward pass, and it manages to follow text instructions more faithfully than prior methods while running about 2.4 times to 28.5 times faster. The paper is titled, Feed Forward 3D Editing via Text Steerable Image to 3D. And as we will see later, the performance and data efficiency claims are pretty striking. Figure 1 lays out the whole idea visually, showing how Steer3D plugs text instructions into an existing image to 3D model. The left pipeline adds a ControlNet-style module, so the frozen base model can be steered by language without retraining it from scratch. The bottom panel illustrates the automated data engine that creates about 96,000 synthetic edit examples. The right side shows concrete before and after edits, where geometry or texture changes follow phrases like replace legs with sleek robotic limbs while preserving the original shape. So while Figure 1 introduced the overall system, Figure 2 shows how the data engine manufactures training examples at scale. The pipeline starts from 16,000 Objaverse assets, which are rendered into images. Then a language model proposes edit prompts like add grapes, and a two-dimensional editor applies them. A three-dimensional reconstruction step turns edited images into candidate assets. A two-stage filter then keeps only about 96,000 of 320,000 pairs, discarding those with poor reconstruction or incorrect edits. Alright, Figure 3 explains how Steer3D injects text control into a frozen image to 3D generator. The left side shows the original transformer blocks, which stay locked while still producing the base three-dimensional output. The right side adds parallel ControlNet blocks with extra cross-attention to the instruction, whose outputs are summed into each base block. The bottom icons highlight that both the input image and the text command jointly steer the final crab geometry. So after understanding the architecture, Figure 5 illustrates what the edits actually look like. The large top panel compares pre-edit assets, text instructions, and Steer3D outputs with those from several baselines, and Steer3D usually follows the instruction while keeping the rest of the object unchanged. The middle strip shows more diverse edits, like removing a head or leg, that still preserve identity. The bottom row highlights a key strength, because Steer3D edits unseen backside geometry that a two-dimensional front view method misses. So, after those visual examples, Table 2 backs things up with numbers for texture edits. The table reports LPIPS for how correct the edit looks, and chamfer distance and F1 score for how well geometry stays consistent. Steer3D has the best LPIPS and chamfer distance and F1 across both seen and unseen assets, so it changes texture while keeping shape intact. The gains are large, with roughly half the geometry error and more than double the F1 score of the next best method. Well, after Table 2 focused on texture, Table 1 turns to geometry edits, splitting results into removal and addition, and into seen versus unseen assets. The table reports LPIPS for visual similarity, chamfer distance for geometric error, and F1 score for how accurately the requested change happens. Across every column, Steer3D has the best numbers, with the lowest LPIPS and chamfer distance and the highest F1. The authors summarize this as roughly 64% higher F1, 63% lower chamfer distance, and 53% lower LPIPS than the next best method. So while Table 1 focused on edit quality, Figure 7 compares inference times across editing methods. The full bar chart shows that LL3M and DGE are extremely slow, taking about 336 and 313 seconds per edit. The middle bars for Tailor3D, Shape LLM, and Edit Trellis still take between about 28 and 97 seconds. The short purple bar on the right marks Steer3D at roughly 12 seconds, which is 2.4 to almost 29 times faster. Steer3D shows that you can bolt language control onto existing image to 3D generators, get higher quality edits, and still run an order of magnitude faster than older pipelines. The broader message is that smart adapters, synthetic data, and preference training can cheaply add new modalities to powerful models. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.